In this lesson, we're going to take a look at how to use proportions to solve for missing sides and similar figures. Similar figures have the same shape, but not necessarily the same size. So you can see an example of two similar triangles on this page. Our essential question is, how are we going to use proportions to solve for missing sides and similar figures? So the first thing we need to understand about similar figures is that their sides are proportional. So if we set up a ratio of two, they're called corresponding sides. So when we look at these figures, this side corresponds to this side. So if we set up the ratio of those two sides, 4:6, it will equal the ratio for any other two corresponding sides. So we could look at 3:x. Once we have our proportions set up, we solve it like normal. In this case, our x is in the denominator, so we're going to flip both ratios. Noticing that we have x divided by 3, we're going to solve for x by multiplying both sides by 3 in order to cancel that denominator. On the right-hand side, that leaves us with x. On the left-hand side, 6/4 can be simplified. They both have a common factor of 2, so I'm going to divide each of those numbers by 2. Neither of the numbers in the numerator are divisible by 2, so I'm simply going to multiply. So x is equal to 9/2. Next, we're looking for a missing side that's a binomial. Notice that we have g plus 2. One way to set up your proportions so that you don't end up with a variable in the denominator is to start with the side with the variable. So g plus 2 corresponds to 5, so I'm going to start with that ratio, equals. Now when you set up your second ratio, you must always set it up the same way you set up the first one. So we started in the larger figure for our first ratio, so we need to start in the larger figure for our second ratio as well, and then we went to the smaller figure, so we go to the smaller figure for the denominator. This time we don't need to flip to solve because we set it up so that our variable was in the numerator. So we're going to cancel that division by multiplying by 5 on both sides. So on the left-hand side, those 5's cancel, leaving me with g plus 2. On the right-hand side, again, 10 and 4 can be simplified, so I'm going to divide each of those by 2. And we have 25/2. Now we need to subtract 2 from both sides to solve for g. However, the right-hand side is a fraction, so when I subtract 2, I need to find a common denominator. So I'm going to start by putting my 2/1, and notice that my common denominator is 2. So I'm going to multiply my 2/1 by 2/2, so that gives me 25/2 minus 4/2. Notice that 4/2, or 4 divided by 2, is equal to 2. So I didn't change the value of 2, I just changed what it looks like so that I can have that common denominator, so that now I can subtract in the numerator and we leave the denominator alone. So g is equal to 21/2. The first two that we looked at, our shapes were set up with the same orientation. So that meant when you looked at them, you could see the similarities. Now when we look at them, you can tell that our larger rectangle was rotated 90 degrees from the smaller rectangle. So what that means is we need to be extra careful when we set up our proportion. I'm still going to start in the larger rectangle with my variable so that that ends up in the numerator and I don't have to flip. That makes an extra step for me. Notice that I used the longer side in the larger rectangle, so I'm going to use the longer side in the smaller rectangle so that those corresponding sides are still in the same ratio. Make sure when your shapes have a different orientation that you do not take the long side from one and the short side from another. That will not get you a correct answer. All right, I started in the larger rectangle to begin with, so I need to start in the larger rectangle for my second ratio, and the shorter side in the smaller rectangle is 7, so that goes in the denominator. In order to solve for y, I need to multiply both sides by 13 to cancel my denominator. 13 has no common factor with 7, and neither does 9, so I'm going to multiply 9 by 13, and that will give me 117 over 7. And our last example, this time we have a binomial, and they have a different orientation. So again, I'm going to start with the side with the variable, so that ends up in a numerator. And notice that of the two sides that I know in that shape, it's the longer side. So when I go to the first shape, I am going to take the longer side to complete my ratio. Going back to the first shape, the larger shape, I'm going to take the shorter side this time, and then the shorter side in the smaller one. All right, so multiplying both sides by 12 to cancel my denominator. 2n plus 2 on the left-hand side. And my 12 and 8 have a common factor on the right-hand side, so I'm going to divide them each by 4. And 12 is divisible by 2. 12 divided by 2 is 6, so I end up with 3 times 6, or 18. Subtracting 2 from both sides, I get 2n equals 16. And dividing both sides by 2, I get n equals 8. Here are two U-Try problems for you, one with the same orientation and one with different orientations. So make sure you think carefully about how you're setting up those ratios.